Let's study chemistry together with CBSE Chemistry Tips and Tricks.
The rate constant for the first order decomposition of H₂O₂ is given by the following equation. You can see the equation, right? And here it is K by T. Okay, calculate activation energy for this reaction and at what temperature will its half period be 256 minutes. While seeing this equation, what you are understanding? You have to understand it is the log of Arrhenius equation. What is Arrhenius equation? K is equal to AE raised to minus EA by RT. Correct? Take log on both sides. Okay, ln log. Okay, ln K is equal to ln AE raised to minus EA by RT. Okay, now you have to use the log rule. Log AB is what? Log A plus log B. Correct? So what is that? Log A plus log, what is, this is A here, okay? And this is B. So log E raised to minus EA by RT. Now again another rule. Log E raised to X is what? X. So you can write like what? Log A plus, here you can see log E raised to X. So what is X? Minus EA by RT. So you can write like minus EA by RT. Correct? Got it right? Now see, you can simplify like log K is equal to log A minus EA by RT. Clear? Now if you check the equation, you can see in the question it is not ln log. It is log log, right? How to convert it? Ln x is equal to 2.303 log x. Do that conversion here. So 2.303 log K is equal to 2.303 log A minus EA by RT. Clear? Now divide the whole equation with 2.303. Complete. Okay. So you will get what? Log K is equal to log A minus EA by 2.303 RT. Clear? See, when you divide this term with 2.303, 2.303 get cancelled. Here also same. Okay, here it become what? EA by 2.303 RT. Clear? So this is what we got, right? Now see, write the equation in the question. So what is that? Log K is equal to 14.34 minus 1.25 into 10 raised to 4 K by T. Correct? If you check these two equations, you can see that they are exactly similar and comparable. See, log K. Here you can see log A value here, right? Minus is there. Now EA by 2.303 RT can compare with what? 1.25 into 10 raised to 4 K by T. Got it right? It is similar and comparable. Okay, so what you can write? EA by 2.303 RT is equal to 1.25 into 10 raised to 4 K means Kelvin by T, temperature. Here also you can see T, LHS and RHS, so you can cancel it. And what we are supposed to find? We are supposed to find EA, correct? EA. What we are supposed to find? EA, right? EA. So write the equation for EA. EA is equal to 1.25 into 10 raised to 4 Kelvin into. Take this part to the RHS. So 2.303 R. What is R? 8.314 Joule Kelvin inverse mole inverse. Why we are writing this unit here? Because to cancel this K. Okay, K into K raised to minus 1, it become 1. Correct? It cancel off. Okay, right? Now we have to multiply all these things, right? On multiplying, you will be getting like 239,340 joule per mole. Now, if you want answer in kilojoule, divide this with 1000. So what is that? 239.34 kilojoule per mole. Both are okay, but normally activation energies are represented by kilojoule per mole. So you can prefer this. That's it. So we got the value of EA. Now we have one more task, right? What is that? You have to find at what temperature will its half-life period be 256 minutes. Okay, we can try that. So our task is to find temperature when half-life period is 256 minutes. Okay, so they have already provided an equation, right? Log K is equal to 14.34 minus 1.25 into 10 raised to 4 Kelvin by T temperature. Right. Now, see, we have T half with us. If we know T half, we can find K. Once we find K, you can substitute that K here and you can find temperature. This is Kelvin and this K is rate constant. Okay, understand that. This is rate constant and this is Kelvin. Okay, we can check. So they have given half-life period. What is that? T half is equal to 256 minutes. So in second it will be what? 256 into 60. Correct, right? Now how to find K? We know K is equal to 0.693 by T half. You remember this, right? Standard equation for T half is what? 0.693 by K. So K will be what? 0.693 by T half for first order reaction. Correct, right? Okay. Now, see in the question it is given, okay, first order reaction. Okay. So 0.693 by 256 into 60. You have to calculate it and you will get 4.51 into 10 raised to minus 5. Minus 5. What is the unit? Second inverse, because it is first order reaction. Okay. Now substitute that K here and find T. Very easy, but only thing you must know how to use logbook. Okay. So log 4.51 into 10 raised to minus 5, which we already got, is equal to 14.34 minus 1.25 into 10 raised to 4 Kelvin by temperature. Okay. See, if you check LHS, you can see log AB. So what is log AB? I already explained you, right? That is log A. What is A? 4.51 plus log B. What is log B? Log 10 raised to minus 5. Log AB is log A plus log B is equal to 14.34 minus 1.25 into 10 raised to 4 Kelvin by temperature. Okay, now log 4.51 is 0.6541 plus log 10 raised to minus 5. See, again you have a rule, right? Log 10 raised to x is x. Log 10 raised to x is x. So log 10 raised to minus 5 is what? Minus 5. Okay, so 14.34 minus 1.25 into 10 raised to 4 Kelvin by temperature. Okay, you can simplify like what? 1.25 into 10 raised to 4 Kelvin by temperature. I take this whole part to the LHS. Okay, and that is equal to 14.34 minus, see I'm taking this whole part to RHS, so minus 0.6541 plus 5. Got it? Now what? 1.25 into 10 raised to 4 Kelvin by temperature is equal to, you have to do the calculation on RHS and you will be getting like 18.6858. What is our task? Finding temperature, right? So take temperature to RHS, okay, and 18.6858 to LHS. So what you will get? You will be getting like 1.25 into 10 raised to 4 Kelvin by 18.6858 is equal to temperature, and temperature is what we are supposed to find. On calculating you will get temperature is equal to 669 Kelvin, approximately 660 69 Kelvin, approximately 669 Kelvin. Hope all of you understand. See, from T half we find K. Once we find K, we substitute that value of K in the equation which they give, which is comparable with the equation of Arrhenius equation. Got it right? Hope all of you understand.